record. Full screen and share. So today, we're going to talk about adding and subtracting decimals. All right? So real quick, let's just go back. Let's review what a decimal is first. So last time we spoke, we talked about decimals, about rounding, comparing them, converting. But just remember that a decimal, they're like fractions in the sense that they represent part of a whole, okay? So we learned how to read them. The key here is to make sure you put the THS on the end of each one of the words so I know it's a decimal. Let's see here, what else? Converting from a decimal to a fraction, all you have to do is write it out in words. And then based off the place value that you say, like hundredths or tenths or thousandths, you know what the denominator will be. Always make sure that they're reduced. When comparing, you literally just start on the left and you compare the numbers. If they're the same, just move to the right. We learned a little trick or a little technique for comparing negative decimals, which is to compare their absolute values. And then whatever number is like greater than, you do the exact opposite for the negatives. And then rounding, when you round the decimal, just like any other number, underline a place value, draw an arrow to the right, and make a decision. So today, we're going to add or subtract. And it's actually very simple, okay? So to add or subtract decimals, I'm looking in the box right now. You're going to write the decimals so that the decimal points line up vertically. Add or subtract, as with whole numbers, place the decimal point in the sum or difference so that it lines up vertically with the decimal points. And here's a little helpful hint. Sometimes when you add a decimal, like 3.2 plus 15.57 plus 0.11, you can actually put zeros in the spots where there's no number. And that kind of keeps everything nice and aligned. All right? So let's just do some examples, because really that's it. I mean, you already know how to add numbers. Now it's just a matter of just adding decimals, okay? So give me a second here. I need to change my marker. Go to that one. So for our first example, I'm just going to align everything. So I write 0.0125 or 0.125. And then I'm going to align the decimal and write my number. Okay? If you want to, you can go ahead and fill in some zeros wherever you see spaces. And now it's just a matter of adding straight down. So 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 8 is 9. Put a decimal. 0 plus 2 is 2. 0 plus 2 is 2. And 0 plus 4 is 4. And there's your end result. It's as hard as it gets. Right there. All right? So like I said, it's all about aligning the decimal places properly. Okay? Let's look at letter B. So we have 11.21. Let me write a little larger. So there's 11.21, 46.013, and then put my decimal, because I have a pretty large whole number here. 362.5. I will put zeros in the spots where I think I need them, just to keep everything nice in order. Now I just add straight down. 3, 2, 7. Look at my decimal point, now it's all nice and lined up. 1 and 2 is 7, plus 2 more is 9. 6 and 4 is 10, plus 1 is 11. Carry the 1. For 419.723. Are there any questions? All right, now, with subtracting, you're going to approach this the same exact way. Align everything, and it's really good if you put in the zeros for subtracting. So let me come over here. I'm going to do it to the right because I got more space. All right. So since I'm subtracting these two numbers, I put my 0 in where I need it. And now hopefully you can see that, okay, I got to borrow. So the 2 becomes a 1, and the 0 becomes a 10. So I get 10 minus 8, which is 2. Now 1 minus 6, I have to borrow again. So the 7 becomes a 6, and the 1 becomes an 11. 11 minus 6 is 5. 6 minus 0 is 6. Decimal. And 9 minus 4 is 5. Are there any questions so far? All right. I want you to go ahead and do D and E then. So go ahead and do D and E for me. Yes, I'm listening.
So since there's no decimal for that 210 minus the 68.22, where does the 210 go?
So let's think about that for a second. So let's pretend that the 210 and the 68.22, let's pretend that those are dollar amounts. All right?
Okay.
So if you had $210 and you saw that like on the cash register, would there be a decimal there?
No.
Are you sure?
Well, yeah, there would. It would be behind the 0.
It would be behind the 0. Good. So any whole number will always have a decimal point to the far right.
Okay.
So you nailed it. You answered your own question. So the 210 really has a decimal point. It's to the far right. Okay?
Yeah.
Good job. All right. Are we done or do we need more time? All right. I'll give you a couple more minutes.
All right. Yeah, I'm back.
Oh, there you are. Okay.
Sorry about that.
No, you're okay. I got your message.
My volume's not. Every time I leave it, then it works.
Do you, Prechi, have you turned your computer off and on again since the last time we spoke? Or do you just always leave it on again?
No, it's on now, but.
Right. What I'm saying is when you're done with it, like, at night.
Like my laptop?
Yeah.
No, I turned it off.
Okay. Yeah, you should always restart it or at least turn it off.
Yeah, I don't know why it's staring at that.
All right, so let's go over these two problems real quick, okay? So, 210 minus 68.22. So, once again, I had to fill in for my zeros. And as long as we're careful with this, all right, everything should kind of just fall into place. So 0 minus 2 I can't do. I need to borrow. So that becomes a 10 and this becomes a 9. But in order for me to borrow from there, I had to borrow all the way over here. So this becomes a 10. Does that make sense, everybody?
Yeah.
Okay. So 10 minus 10, 8. 10 minus 10, 8. Put a decimal. 9 minus 8 is 1. Oh, looks like I got to borrow again. So that turns into an 11. This turns to a 1. 11 minus 6 is 5. And 1 minus 0 is 1. Now, you can always go ahead and check yourself. By adding. So, oh wait, why did I do that? You guys see my mistake?
Yeah, that's wrong.
Yeah, this is supposed to be a 9, correct?
Yeah, your answer should be 141.7.
Well, 151.78. I'm pretty confident with the 151. Why did I make that a 10? Anybody ever make a mistake where you have no idea why you did it? Yeah, I definitely just did that. So let's check my answer real quick. 8 plus 2 is 10, carry the 1. 1 plus 7 is 8, plus 2 is 10, carry the 1. 1 plus 1 is 2, plus 8 is 10, carry the 1. 1 plus 5 is 6. Did I make another mistake? Who corrected me and I said no? Savannah, I am so... You know what? We're going to do this problem all over again, Savannah. Because you were absolutely correct. Man. I guess it's one of those days for me. Let's try this all over again. So, first. Write out the problem. Align the decimal. Second. Let's put the zeros in. Third. Subtract. So, we need to borrow. And I need to borrow from all the way over to here. Initially. All right? So this becomes a 10. This becomes a 9. That becomes a 9. So far, so good, everybody.
Yeah.
Now, that becomes a 0. Are we good so far?
Yes.
All right, and that's going to become a 1. So now, 10 minus 2, 8. 9 minus 2, 7. 9 minus 8, 1. 10 minus 6, 4. And 1 minus 0, 1. Savannah, how are we looking?
You look better.
Now, let's check ourselves. 8 and 2 is 0. Carry the 1. 1 plus 7 is 8 plus 2 more is 10. Carry the 1. 1 plus 1 is 2. Plus 8 is going to be 10. Carry the 1. 6 and 4 is 10. Plus 1 is 11. Carry the 1. And we come up with exactly 210. So that problem took entirely way too long. And it's because I am rushing way too quickly. Are there any questions? All right, so just be careful. Don't do what I just did, which is be reckless. Now let's look at letter E. Now, letter E, we've seen problems like this before. Notice the signs in front of the numbers are the same. So what am I going to do with these two decimals then? Thank you, Mike. So we're going to add them and keep the sign. So I know the answer is negative. All right, let me catch up with you. So I'm just going to add them together. 4 and 6 is 10. Carry the 1. And then 9 plus 5 is 14. Plus 1 more is 15. So you get negative 15. Everybody, are we on the same page?
Yeah, but I have a question.
Go for it.
You know on the left-hand side where it says the negative?
Yeah, what do you...
Can you put that on the left-hand side as well, where it says 5.4 or no?
What do you mean? Like, how come I didn't put a negative right here?
Yeah.
Because this is just my scratch work. I'm applying my rules for signed numbers, which is all the way back in chapter 2.
Okay.
Okay?
But can we put that if we want or no?
You could, but I don't know why you would. Put it that way.
Okay. I
Like-
was just looking at that one.
Well, let me ask you, like, why would you want to put that there?
No, that's true. All right. Never mind. Yeah. There's no need.
Okay. Yeah, yeah. I'm just trying to figure out, like, why would you want to put that? Like,
Because like it was over there, so.
okay, yeah. No, all I'm doing, all the way back here. Let me hold on one sec, Bree. Here's what we're doing right here. It's this rule. So this was back in chapter 2, section 2. When the signs of the numbers are the same, add the numbers, keep the sign.
So just keep it. Yeah. All right.
Okay?
Yeah, I don't know why I would want it. Okay. Thank you.
Yeah, no problem. No problem. It's a good question. All right. Now let's look at letter F. Now, I see two negatives back to back. When you see that, what are you thinking?
You do what's in the parentheses first.
Okay, so if that's the case, hold on one sec, because I agree. Whoever said the positive thing, I agree with. But let's go with this line of thinking. Inside the parentheses, it's just a number. There's nothing I can do. So we're back to this now. Two negatives back to back. When I have two negatives back to back, do I rewrite the problem? Yes or no?
Yes.
How? Well, somebody said it earlier.
Yeah, that was me.
What do you make it?
Positive.
There you go. So we rewrite the problem as negative 1.05 plus 7.23. Now that is chapter 2, section 2 all over again. When the signs are opposite, okay, you're gonna want to figure out which number is further away from 0. That's the absolute value thing. So if we think about this, 7.23 is larger. So what I'm going to do is take 7.23, subtract 1.05. All right, I got to borrow. So this becomes 13. That becomes a 1. 13 minus 5 is 8. 1 minus 0 is 1. And then I got my decimal point. 7 minus 1 is 6. And since 7.23 is larger, and the sign in front of 7.23 is now positive, I know my result is going to be positive as well. So 6.18 or 6 and 1800ths. All right. Are there any questions? Are we good?
Yeah.
All right. Perfect. So a couple more objectives, not too many more. Objective 2, we're going to estimate when adding or subtracting. And example, add or subtract is indicated, then estimate to see if the answer is reasonable by rounding the given numbers, rounding the given numbers and adding or subtracting those rounded numbers. So, first thing we're going to do, let's just add. Let's add the way it looks. 58, I need some more space here. 58.1 plus, put my decimal, 97326. Put a 0. So we're just going to add real quick. 7, 1 and 9 is 10, carry the 1. That's going to be 15, carry the 1. That's going to be 8 and 3. So 385.07 is the actual answer to this. Now sometimes, and I do this all the time when I'm shopping, because in shopping you always have decimals. You know what I mean? Like the cents are always there. Like it could be 15 cents or 99 cents or something. When they want you to round to see if the answer is reasonable, what I'm going to do is I'm going to say, okay, well, this number right here is basically 58. In other words, I'm going to round to the nearest whole number. And 326.97, that's basically 327. If I'm rounding to the nearest whole number. So when I go ahead and add these, 7 and 8 is 15. Carry the 1. That's going to be an 8. and 3. So I get 385. So does my answer make sense? Absolutely. All I did was just round it to the nearest whole number, and that gave me an idea. Does that make sense, everyone? What's that?
Yeah.
Okay, good, good. We're actually moving pretty good here. So objective 3, we're going to evaluate, and hopefully you remember how to evaluate. All you do is write out the expression. In this case, it's going to be y minus z. And then you make your substitutions. Personally, I like to put parentheses first and then write in the numbers. Now, I'm just going to subtract to see what this is. So 11.6 minus 10.8. I have to borrow. So this turns into a 16. That turns into a 0. 16 minus 8 is 8. 0 minus 0 is 0. And 1 minus 1 is 0. So this is nothing more than just 0.8. Any questions with that? Are we getting bored of adding and subtracting decimals already? You could be honest with me. All right. How about that next example? Why don't you do the next example? Let's see if you remember how to do that. All right. Did anybody get an answer yet?
4.0.
4.0? I don't know how you got that. Can you explain what you did?
I subtracted 7.8 minus 3.8.
Okay, now I need to ask you a question. Why are you doing that? Can you, in other words, Prechi, could you read the question for me again?
A solution of the equation.
Whoa. You missed something very important. Unless maybe your mic cut out or something like that. Try it again.
Yeah, I did.
What?
Yeah, I know what I did. Never
What?
mind.
What did you miss?
Yeah, I missed out. Is 12.1 a solution?
Yeah,
Or
just
yeah, I didn't know.
exactly. Just because you see an equation, there were words before that. Like you got to make sure we are reading the directions completely.
Yeah, it's wrong.
So is 12.1 a solution of the equation y minus 4.3 equals 7.8? So what they're asking is if I took that letter y and substituted 12.1 and subtracted 4.3, do I get 7.8 as an answer? So I'm just going to come off to the right, just rewrite it. Let's borrow. That's going to be an 11. That's going to be a 1. 11 minus 3 is 8. 1 minus 4 I can't do. I have to borrow again. So 11 minus 4 is 7. So is 12.1 a solution?
Yeah.
Yes. Okay. How are we looking so far, everybody? All right. I guess good, because nobody's saying anything. Next one. How do we combine like terms? Does anybody remember?
Any numbers with the same variables you combine.
Are you sure? Like, that's it? They just have to have the same variable. Nothing else.
And the same sign.
Same sign?
The same,
Be careful, Mike.
Is it a constant term?
No, we have variable terms, we have constant terms. So, like, for example, those two terms right there that I have underlined are variable terms. And then the ones with the double underline are constant terms. But we haven't really nailed how to combine like terms. Like, we're missing one little piece. So I agree. Combine like terms. I'm gonna just abbreviate it CLT. You definitely have to have the same variable. The question becomes, what's that second thing? Because there is another thing.
The same constant?
Not the same constant. Here, I may give the answer away. Can I combine those two?
numbers 1 as the exponent.
Okay, so when I combine like terms, I have to have the same variable and what else, Mike?
Same exponent.
Same exponent. Very good. All right. So now, when we look at our problem, we have negative 4.3y plus 7.8 minus 20.1y plus 14.6. So the y's both are raised to the first power, so that's good. Okay? So for us, we can combine them. The 7.8 and the 14.6, they're just constant terms. We can combine them. So go ahead and combine them for me, please. Okay, did anybody get an answer yet?
22.4 plus negative 24.4.
Oh, negative 24.4.
Minus, yeah. Wait.
All right, let's do this together.
24.4 y
So negative 22.4,
24 though.
negative 24.4,
Yeah.
y
Plus 22.4.
plus 22.4. Boy, those numbers are kind of too close together. So let's do this just to make sure we're correct. So the negative 4.3y minus the 21.1y. Now, I know no matter what, when I combine these two things, I'm going to have a y, and it's also going to be negative. How do I already know that? The signs in front of each number are negative. So all I have to do is combine the numbers. Oh, sorry. And then keep the sign. So negative 24.4y. So that's correct. Now, do the same thing with the constant terms. The signs in front are both the same. So I'm just going to add 7.8 and 14.6 together. 8 and 6 is 4. Put a decimal and carry the 1. 1 and 7 is 8. Plus 4 more is 12. Carry the 1. And 1 and 1 is 2. So, Mike, good job. All we're going to do is just slow down a little bit. That's it. Are we good? Are there any questions? All right. So the last problem that we have is just a little word problem. I like this problem, but then I hate this problem at the same time, because if you're like me, you probably hate paying bills. Am I correct? I mean, does anybody really like paying bills? Or would you rather just want to keep all your money?
I'm the second one.
Yeah, I'm with you, Preachy. I'd rather keep all my money. Unfortunately,
That for a while.
yeah, like right now, it's really cold outside and my house is kind of warm. So I like that. But I have to pay for that. I have to pay for that privilege. So, example, find the total monthly cost of owning and operating a certain automobile given the expenses. So, we got a monthly car payment, we got some insurance, and we got a gas bill or gasoline bill when you go to the pump. And this is something that I think sometimes people, when they buy a car, they really don't think about it. Just because you have if you have a car payment, that doesn't mean that's how much it costs to operate that car per month. You still got to pay for insurance, and you still got to put gas in it. So even though you may have, let's say, a $300 car payment, your car payment is actually probably going to be around $500-$600 because you got insurance and you got gas to worry about as well. On top of that, you hope the car doesn't break down or you need tires or something, because that's even more money. But for now, we're just going to find a total monthly cost. When you see the word total, you should be thinking add. So all we're going to do is just add all these numbers together. So as long as you just align a decimal, you keep it nice. 8 and 3 is 11. Carry the 1. Now I'm going to skip around here a little bit because I see 5 plus 5 is 10. And 1 and 6 is 7, so that's going to be 17. Carry the 1.
0.52, not 0.53.
Oh, look at me. I'm already cheating people out of a penny. All right, so there you go. That's fixed. Now, 7 and 3 is 10. 1 and 2 is 3, so that's going to be 13. Carry the 1. Let's see here. What else do we got? 1 and 6 is 7. Plus 2 is 9. Plus 5 is 14. Carry the 1. And then that's going to be 7. So this person, whoever it is, spends $743.70 just to drive a car. That's pretty expensive if you ask me. I think this car payment of $500, that is very high. But that's just my opinion. I mean, if I were making $1 million a year, a $500 car payment means nothing. But, an average person, that's a lot of money to drive.
If you were making $1 million a year, you probably wouldn't be making car payments.
Mike, you're probably right. I would just go to the car dealership and buy a car and just pay cash for it. I agree with you on that one. All right, are there any questions with adding and subtracting decimals? Okay. Section 3. Now, section 3, we're gonna learn how to multiply decimals, okay? So there is a technique to do this. It's not difficult at all right? It's just a matter of just keeping things in order. So to multiply decimals, step 1, you're just gonna multiply as if they were whole numbers. In other words, who cares about the decimal place? Just go ahead and multiply, okay? Step 2, the decimal point is going to be, the decimal point in the product will be nothing more than the number of places in the first number and the number of places in the second number. You add them together, and that's going to be the number of decimal places that you need. So what you're going to do for step 3 is you're going to place the decimal on the far right and move it to the left the same number of places that you counted in step 2. So let me show you what I mean. With this very first example, the 34.8 times 0.62. I'm just going to go ahead. Oops, sorry, wrong place. I'm just going to go ahead and multiply the two numbers together. That's it. I don't care about decimals right now. So 2 times 8 is going to be 16. Carry the 1. 2 times 4 is 8 plus 1 more is 9. And then 2 times 3 is 6. Now I put a 0 because I'm going to multiply 6 times everything in the first number. So I'm starting in the tens position. 6 times 8 is 48. Carry the 4. 6 times 4 is 24 plus 4 more is 28. Carry the 2. And then 6 times 3 is 18 plus 2 more is 20. All right. So now when I add these two numbers together, I'm going to get the product. 6, 17, carry the 1, that's going to be 15. Carry the 1 with a 2. So I know numerically the number 21576 is the answer. The question becomes, where is that decimal? So step 1 is done. Here's step 2. In the first number, there's only one decimal place. In the second number, there are 2 decimal places. So that gives me a total of 3. So what I'm going to do, I'm going to put the decimal on the far right, just like step 3 tells me. Place the decimal to the far right. And then we're going to move it to the left 1, 2, 3 spots for a final result of 21.576. Does that make sense, everybody? Are there any questions with how we did that? So, if you really take a step back and you look at this, the only thing that I'm really teaching you here is just where to place the decimal. We should already know how to multiply whole numbers. That was all the way back in chapter 1. So, let's go ahead. Let's look at the second one here. 0.0641 times 27. Now, I'm going to go ahead and set this up. 0.0641. 27 underneath. Once again, you just multiply. That's it. 7 times 1 is 7. 7 times 4 is 28. 7 times 6, is 42. Plus 2 more is going to be 44. All right, let me erase my carryover. Put a 0. 2 times 1 is 2. 2 times 4 is 8. 2 times 6 is 12. Now I add the two products together. So I get a 7. 10, carry the 1. Let's see, that's going to be 12. 13. Carry the 1. 5 and 2 is 7 with a 1. Now I count decimal places. 4 and 0. So I have a total of 4 decimal places. So I place the decimal on the far right. 1, 2, 3, 4 places to the left. And there's my final result. Are there any questions with how I did that? All right. I want you to do the next one. Okay, did anybody get an answer yet?
Negative 6.57.
Negative 6.57. Okay, so let's go ahead. Let's do this real quick. I'm not saying you're wrong, Mike. I just want to make sure, that's all. So the first thing I'm going to do is just multiply the numbers. The easy part is a positive 7.3 times a negative 0.9. I know the answer is going to be negative because a positive times a negative is a negative. The question becomes, what's the number? So set it up. 9 times 3 is 27. Carry the 2. 9 times 7 is 63. Plus 2 more is 65. One decimal place for a total of 2. Move it 2 places to the left and put a negative out front. Negative 6.57. Mike, good job. How's that golf game?
Dude, I shot a 46 on a 36 yesterday.
So you were 10 over.
Yeah.
Ugh.
Not bad.
Ugh.
Yeah.
For me, that'd be amazing golf. For you, not that good.
Yeah.
All right. Let's look at the next problem. So, with this next one, we're going to just multiply and estimate to see if the answer is reasonable. We did this problem, we did a similar one in the previous section. Let's do this one the exact opposite way. First thing I'm going to do, I'm going to estimate and get an idea of what the answer should be. So, if I estimated this number, 30.26 to the nearest whole number, it's going to be 30. And the 2.89, that'll round to 3. So 30 times 3 is 90. So I know my answer should be somewhere around 90. Now, excuse me. Let's go ahead and find out, okay, what is the actual answer? And if we're close to 90, then we know we did something right, which is a good thing, okay? So 30.26 times 2.89. Now this one's going to take some work. So 9 times 6 is 54. 9 times 2, I'm going to zoom in so we can see it. 9 times 2 is 18. Plus 4 more is what? 22? 9 times 0 is 0. Plus 2 is 2. 9 times 3 is 27. All right. Let me erase my carryovers. Put a 0. Now we're going to multiply everything by 8. 8 times 6 is 48. 8 times 2 is 16, plus 4 more is 20. 8 times 0 is 0, plus 2 is 2. And then 8 times 3 is 24. Erase my carryovers and put 2 zeros now. Now I'm going to multiply everything by 2. 2 times 6 is 12. 2 times 2 is 4, plus 1 more is 5. 2 times 0 is 0. 2 times 6 is 6. Now, I just need to add everything up. I get a 5. I get 10, so I have to carry over the 1. I get another 5. 7 plus 2 is 9, plus 5 is 14. Carry that over. 1 plus 2 is 3, plus 4 is 7. And 2 plus 6 is 8. Now for the decimal places. Oh, I'm moving way too fast. I have 2 of them here, and 2 of them here for a total of 4. So I put my decimal on the far right, and move it 4 places to the left. 1, 2, 3, 4. So here's the actual answer. 90 was my estimated answer. Am I pretty close to 90? Yes or no?
Yes.
I think so. I'm only off by 3, roughly. Okay? So that's it. That's all they want you to do when they ask you. Estimate to see whether the answer is reasonable. All right? Remember, estimation is just a really good guess. That's what it is. All right? Are there any questions? Okay, here comes the easy part of the day. Not going to lie. Whenever you multiply decimals by powers of 10, meaning 10, 100, 1,000, 10,000, so forth, you don't have to write out everything. All you got to do is just follow this little step right here. You're going to move the decimal place or the decimal point to the right, the same number as zeros in that number of 10. So, for example, 46.8 times 10, well, I have 1 0, so I move the decimal place one place to the right. So it equals 468. For the second example, 201.004 times 100. Notice there are 2 zeros. So I take my decimal and move it 2 places to the right. 201.00.4. For letter G, the last one, there are 3 zeros. So I need to move my decimal place 3 places. So give me a second because I'm going to write this. 1, 2, 3. Now here's a situation where we actually have to add a 0 right there. So the answer, negative 2,330. This is one of the reasons why the metric system, maybe you've heard of that. It's how other countries, other than the United States and England, how they determine lengths or masses or weights or something like that. They use the metric system. This is why the metric system is so easy, because all you're doing is multiplying or dividing by 10. That's it. So let's recap real quick. If you multiply by a power of 10, such as 10, 100, 1,000, just move the decimal place to the right, the same number of zeros. Okay? Are there any questions with that? Like I said, this is the easy part, because you're just moving a decimal place. Now, what if we looked at an example like this, where we're multiplying decimal powers of 10, such as, now look at the difference here. 0.1, 0.01, 0.001. Notice we're multiplying by a decimal. As long as it's a factor of 10, all you're going to do is move the decimal point to the left the same number of places as there are decimal places in the power of 10. So the first example, 6.94 times 0.1. Notice 1 decimal place. So I move the decimal to the left 1 spot. 0.694. In example I, notice there are 3 decimal places. Okay? So I move it 3 places to the left. So let me rewrite the number. 1, 2, 3. Here, I need to fill it in with some zeros. And then I just like to rewrite the number so it looks nice and clean. 0.00392. Are there any questions with that?
Wait, how is this different than the first one? Right?
So the first one, look at the numbers that we're multiplying by, and I'll highlight them for you, okay?
Okay, they're whole.
Yeah, they're whole numbers. Down here, they're decimals. So if they're whole numbers, move to the right. If they're decimals, move to the left. Does that make sense? All right, let's see what else we have. I forget what else we have. You know what? Why don't we do this? We did a lot today. Let's call it a day. We did a lot today. We'll come back. We'll look at these last couple examples here on Monday. And then we're going to probably spend the entire class period on dividing decimals. That is the hardest one. Once we get over that hump, the rest of the semester is easy. All right?
Yeah.
So we'll call it a day here.